This is MAT 175, lesson 39, section 9.4, Vector Applications. And the first thing that we want to look at is we have two forces, or two vectors, acting on each other, which produces a resultant vector. And so these two forces are going to be added together into a third vector. And so we want to find vector direction and magnitude in this lesson. Well, in here we have this angle, alpha, and we have I as our horizontal displacement, and that goes along the x-axis, and J is our vertical displacement, and that is along the y-axis. And we're looking at this as a radius of 1 here. And so here for our angle here we have cosine alpha, comma sine angle alpha. So if we looked at alpha, cosine is adjacent over hypotenuse. So if the hypotenuse is 1, this would be cosine alpha equals to I over 1. So in other words, cosine alpha would be synonymous with I. And sine alpha, that would be the same as opposite, which would be the J. If we had J side here over 1, which is the hypotenuse. So we would say that sine alpha is synonymous with the vertical component, or J. So when we say our vector here in terms of I and J, we use the magnitude, and magnitude here could be configured in terms of speed or newtons or different units. And that's going to be times cosine alpha I plus sine alpha J works. So here we have write the vector V in the form of AI plus BJ, given that the magnitude is 25 and our angle alpha is 330 degrees. So if we were to draw this out, our angle alpha is 330 degrees, and we could say that our magnitude is 25. So it helps to write the formula out first. So here's our vector V, and we have our magnitude, parentheses, cosine is always with I, so it's cosine alpha. So in this case, cosine alpha I plus sine alpha J, and so we know that our magnitude is 25. So this will be 25, and we have cosine alpha, we said that's 330 degrees. I plus sine 330 degrees J. Well, if we look at this here, 330, that's coterminal with 30 degrees. So we could say that this is square root 3 over 2, 1/2 for cosine and sine. So that means this will be 25. Cosine 330 is going to be square root 3 over 2 I. And then sine of 330 degrees, that will be a negative 1/2 J. Well, we don't have to put plus a negative, so we can just make that minus. And so now if we distribute the 25, we get here for so here 25 square root 3 over, I'll put this all over here, 2 I minus 25 over 2j. And that is our vector. Okay, here we have force vectors. A child pulls a wagon with a force of 40 pounds. The handle of the wagon makes an angle of 30 degrees with the ground. Express the force vector F in terms of I and J. So if we were to draw a picture of this, here's our wagon, and here's our 30 degrees, and pulls it with a force of 40 pounds. So the force that would be our magnitude. So we have a magnitude of 40 pounds, and our angle alpha is 30 degrees. And we want to express our vector in terms, and so basically we'll have here magnitude equals to cosine alpha I plus sine alpha j. So this will be 40 cosine 30 degrees. I plus sine 30 degrees j. So in that case, our vector, here's 40 cosine of 30 degrees. That will be square root 3 over 2 I plus sine of 30 degrees, that's 1/2 j. Now if we were to distribute that 40, actually I'm going to write this down here, then that would be 40 square root 3 over 2 I plus 40 over 2 j. And if we simplify that, 2 goes to 40, that's 20. That would be 20 square root 3 I plus 20 j. And that's our vector. Okay, here we have a problem where we want to find the actual speed and direction of a jet. And we'll symbolize that with a j. It has a speed of 515 miles per hour, heading due north. The jet stream, we'll symbolize that with an s. Speed is 100 miles per hour, moving northeast. And there's three parts to this problem. We want to express the velocity of the jet, and we'll call it Vj, and the velocity of the jet stream, we'll call that Vs. Part B, we want to find the actual velocity, which is going to be the sum of these two vectors. Now notice the key word here is velocity. So there's a difference between velocity and speed. Speed just has is a scalar. It's just like a reading on a speedometer. It gives you how fast you're going, whereas velocity gives you both speed and direction. We want to find the actual speed. So in other words, basically what we're doing is we're taking the actual velocity and we're going to find the magnitude to that. And that's going to give us our speed in relation to the wind or the jet stream. So it helps to break this down into two parts, the jet and the jet stream. The jet speed is 550 miles per hour, and that would be your magnitude. So here's our velocity of the jet, is magnitude, parentheses, cosine alpha I plus sine alpha j. Well, if we look here in the direction of the jet was traveling due north. Well, due north, if we're looking at the compass rose, that would be like 90 degrees. So cosine is 0 at 90 degrees and sine is 1 at 90 degrees. So here we go. We have our magnitude is 550, parentheses, cosine 90 degrees I plus sine 90 degrees j. And so that will give us 550, since cosine at 90 is 0, this would be 0I, and sine at 90 is 1, so that would be 1j. Now, if we distribute the 550, we get 550 times 0, that would be 0 still, I, plus 550j. Okay, because that would be 550 times 1. Now, for purposes of adding, to get our true velocity or resultant velocity, I retain the 0, I. And I'll show you why here in a minute. Alright, next we want to find the velocity of the jet stream. So we said the speed of the jet stream is 100 miles per hour moving northeast. Well, if we look direction northeast, theta is always in reference to the x-axis for degrees. So since it's northeast, that splits the difference between 0 and 90. So a northeasterly direction would be 45 degrees. Alright, so now we're moving along. And so cosine 45, that would be square root 2 over 2, I, plus, and then sine 45 degrees, that would be square root 2 over 2j. And we're multiplying all that times our speed of the jet stream, which is 100. Alright, now we're going to distribute that 100. And so 100, if divide into 2, can cancel on the 100, and that's 50. So we simplify that. And then 2 again, cancel on 50, that's 100, and that's 50 also. So this would be 50 square root 2i plus 50 square root 2j. And so we have our vector for our Gulfstream, and we have our vector for our jet. Alright, now what we want to do is we want to find actual velocity, or also known as true velocity, or velocity in relation to the ground. And that is where we're going to take these two velocities for the jet and for the jet stream, and we're going to add them together. Now I like to add the vectors vertically, which I just think it just seems to work better for students. So 0i plus 50 square root 2i, so that would just be 50 square root 2i. And then 550j plus 50 square root 2j, since these two cannot be added together, we would just leave it as 550 plus 50 square root 2 parentheses j. And just leave it like that. It's real easy. So that is our true velocity of the jet in relation to the jet stream. So if we were to calculate that out, we could get decimals for that, but we're just going to leave like that in exact form. Alright, so that's part C. Part D, we want to find the actual speed. Now remember, speed was synonymous with magnitude. So all we're doing now is we are just taking our velocity and finding the magnitude for that. We're taking our vector in terms of I and j, and we're trying to find the magnitude for that. So the I, that's our A, or our horizontal component. So that's like square root of a squared plus b squared. And so this will be 50 square root 2 parentheses squared plus 550 plus 50 square root 2 parentheses squared. And so when we go to calculate this on the calculator, and I would recommend that you try this, you should get approximately, rounded off to 624.7 miles per hour. And that is the velocity of the jet in relation to the jet stream. So notice that it's actually going faster because the jet stream is going northeast and the jet is going north, so it's like not a full tailwind, but is somewhat of a tailwind. So it's going to push that jet faster. And so see that the jet is moving at a faster speed due to the jet stream pushing on it. Now for actual direction, we have here our I and our J components, and so we're going to use tangent for our actual direction. And so that would be opposite over adjacent, right? So that would be J over I. And so since we know that the J was the 550, right, plus 50 square root 2, that's going to go in the numerator. And the 50 square root 2, that's our I, that's going to go in the denominator. And so this is opposite over adjacent here. And our mode in our calculator, because we've been working in degrees the whole time, right? Degrees, everything's in degrees. So we have to make sure our calculator is in, our mode is in degrees. So we're going to apply inverse tangent to both sides, and the tangents are opposites of each other, so they're going to cancel each other out. And so we get inverse tangent for the inverses of each other. So inverse tangent 550 plus 50 squared 2, close parentheses, and I would use parentheses in the denominator, because sometimes when you have 50 times something in the denominator like that, the other part of it gets multiplied instead of divided. And you want to try this out on your calculator, and you get a direction angle of 83.5. Well, we want actual direction. And direction is in terms of north, south, east, west, northeast, southeast, and so on. And the direction theta is in reference to the x-axis, but direction is in reference to the y-axis. So what we have to do here is we have to take 90 minus that angle to get our direction. So it's going to be 90 minus 83.5, and we get 6.5. So this is moving in a north 6.5 degrees east direction.